Hello everyone. Today, I'm going to show you an incredible transformation. As you can see, my garden needs a bit of tidying up. While out in the garden cleaning, I came across this old, rusty angle grinder. What if I told you that this old, seemingly broken angle grinder can be repurposed into something truly powerful? I'm going to begin by removing the existing sanding disc. A special wrench helps unscrew the locking nut, allowing me to take the disc off easily. This step is crucial for gaining access to the internal components and starting our transformation. With the disc assembly completely off, I can now begin a thorough cleaning of the exterior. Now, it's time to open up the housing. I'm using a screwdriver to remove these 4 screws from the head of the grinder. The goal here is to access the motor's core, so I need to be gentle to avoid damaging any salvageable parts. Once the screws are out, I can gently pry open the casing and separate the head from the main body, revealing the internal motor components. Next, I'm removing more internal components, including the carbon brush holders and the motor armature. The main goal here is to isolate the stator, which is a stationary part of the electric motor that contains the primary windings. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'll snip these wires to free the stator from the rest of the grinder's electronics. I'm using a piece of wood to carefully tap the grinder to get stator out. This metal core is crucial for creating our welding machine, as it will act as a transformer. Next, I'm taking a section of PVC pipe and fitting the metal core inside. I'll mark the length I need, and then use pipe cutters to get a clean, precise cut. I'll use pipe cutters to precisely cut the PVC pipe. The PVC pipe will serve as the insulating body for our new homemade transformer. This ensures a snug and secure fit for the stator, which is essential for the next steps. To prepare for secondary winding, I'm clamping the PVC pipe firmly in a vise. Now I'm drilling 2 small holes on either side. These holes will be critical for guiding and securing our new secondary coil. With the holes drilled, I'm taking a red insulated wire and threading it through 1 hole, then wrapping it tightly and evenly around the PVC pipe. This is going to be our new secondary winding. I'm making sure it's snug, as this coil will be responsible for the high current needed for welding. Make sure to keep the turns consistent for optimal performance. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Now, I'm going back to the original stator windings. I will carefully cut off the excess wire. I'll carefully twist the copper ends together to ensure a strong electrical connection. This connection is vital as it will complete the circuit for the new functionality. I will thread the coil on the PVC pipe into the stator. With the red coil in place, I'm now connecting it to the existing internal wires of the stator. I'm also adding a new blue wire on the other side, twisting it to the remaining stator wires. This sets up our primary and secondary circuits. I'll then securely wrap this twisted connection with electrical tape. This prevents any accidental short circuits and protects the wiring from external elements, which is extremely important for any electrical project. I'm stripping the ends of some new blue and red wires and connecting them to the leads of the primary coil. Good. Secure connections are vital for electrical projects, so I'm twisting them tightly and then insulating them thoroughly with electrical tape to prevent any short circuits. Here, I'm connecting the remaining ends of the secondary wires. I'm twisting the copper strands together firmly and then insulating them with more electrical tape. Safety first. Always, I'm making sure all the primary connections are secure and properly insulated. This is the part that will connect to our power source. To provide extra insulation and prevent any movement or stress on internal connections, I'm applying hot glue. This ensures everything stays in place and adds another layer of safety. With the internal wiring complete and secured, it's time to reassemble the grinder's housing. I'll carefully thread the new red and blue wires through the appropriate openings and then fit the front part of the casing back over the modified stator and PVC pipe assembly. I'm carefully fitting our newly constructed transformer back into the original angle grinder housing. It's a tight fit, but it slides in perfectly. I'll then tighten all the screws, ensuring everything is snug and securely in place. Our old angle grinder has been completely transformed into a compact, homemade welding machine. But does it work? I'm stripping the ends of the primary wires and carefully connecting them to a standard AC plug. This will be how our welding machine gets its power. For the output, I'm attaching these welding clamps to the secondary wires. One will be for the ground, and the other for our welding rod. And there you have it, all the components laid out and ready. I'm plugging into a power strip, and we're almost ready to see some sparks fly. I've clamped a sturdy metal bar in the vise. I'm connecting one welding clamp to the bar for ground, and the other will hold our welding rod. Watch what happens when the welding rod touches the metal bar. The intense sparks and the molten metal. It's truly amazing how a simple, repurposed motor can achieve this. See those bright sparks and the immediate melting? This homemade device is effectively acting as a spot welder. It's incredible to see how we transformed an old angle grinder into such a powerful and functional tool. And there's our finished weld. Thank you for watching, and I'll see you in the next video.